Section 6.1, Law of Sines. So let's go ahead and just jump in and do some practice. So I have two questions on this page, and then I've got a couple more slides after this. So question number one, we're given angle A, angle B, and lowercase a, or side A. So because I have a pair, and by that I mean I have an A and I have an A. Because I have a pair, I know that I should be able to use law of sines, assuming this triangle even exists. So I think the first thing I'm going to do, if I have angle A and angle B, I think I'm going to just find angle C. So remember that this is a triangle, so it's a triangle sum has to be satisfied. So if I take angle A, angle B, and angle C, I should get 180 degrees. So plug in what I know. And then subtract. So I know that angle C is going to give me 61 degrees. So there's one of my answers. So let's go ahead and box these as I go so remember which ones I've done. So there's angle C. Now, because I was given two angles originally, I know that there's only going to be one triangle that satisfies if any triangle satisfy it. So now let's go ahead and jump into law of sines and see if we can find the missing sides. So take the pair that you have and create that complete ratio. And then let's go ahead and find lowercase b, or side b, first. So I went ahead and set up my ratio. Now if I go ahead and cross multiply, I don't grab my calculator until I'm done manipulating because I don't want to type in prematurely and then end up rounding and rounding. So if I go ahead and solve for side b, or lowercase b, this is going to be the exact answer. Let's go ahead and type that in. You want to make sure that your calculator is in degrees because these are in degrees. Type it all in, and again I go out to 4 decimal places to make sure that you're accurate to 3. And I got 27.0317. Now I can go ahead and find, it looks like I still need to find side C. So let's go ahead and continue on with this. Still use that complete ratio that I had with the A information. And I'm going to use that sine 61 now, the angle that I found, to go with side C, or lowercase c. So cross multiply and solve. Do the exact same thing that I did with B. And then once I have it all solved down, I'm going to go ahead and type it into my calculator. Again, always make sure that you're in the correct mode. So it looks like lowercase c is going to give us, from my calculator, 24.3662. So that covers our first one. So going back and marking what I have, I found lowercase b, which is side length b, and lowercase c, which is side length c. So just to make sure that I am complete, I should have angle A side A, which I do, angle B side B, which I do, and angle C side C, which I do. Let's take a look at the next example. Notice that I'm also given two angles again, so I think I'm just going to go ahead and try triangle sums. It's going to be the first thing that I would attempt on any problem where I'm given two angles to begin. I plug in what I know, and I see an issue immediately. If I solve for angle C, I'm going to get a negative number, but that doesn't make any sense. So what we can say right now is that no triangle exists with this given information. So we can't have negative angles in a triangle. It doesn't make any sense at all. Let's take a look at the next slide. Okay, same idea. So I'm going to go ahead and just set up my pairs here. So it looks like I have an A and an A. So that's going to be my complete ratio. Looks like the only thing I can solve for right now is C. Set up my ratio. Let's go ahead and cross multiply and solve. And then since it really is just the arithmetic that we're doing now, I am going to go straight to the punch on these. So I would cross multiply and then I would end up dividing. And it looks like I'm trying to find an angle, so I'm going to have to do some inverse trig here. So go ahead and show your manipulation for yourself. I don't need to see it, so I'm going to go ahead and just kind of go straight to the punch on this one. Type this into my calculator. Oh, these are approximations. Now it looks like I get 74.2068 degrees. Now if you take a look at the original what's given to you, I'm given angle, side, side, which is the ambiguous case. So that means that there's a possibility that two triangles are going to exist. With that said, it has to happen immediately if you want to check this, and I'm absolutely going to check it. So what I would do with this first angle is I automatically check and see if there's going to be a second angle that leads me into that triangle, that second triangle. So let's call this C1 that I just found. In order to find C2, C2, if it exists, is going to be the supplement to angle C1. So we should be able to find the supplement. That shouldn't be a problem. So if I do 180 minus C1, and I still have that logged in my calculator, and actually before we do that, I think we should probably store this before we get ahead of ourselves. And since this is C, I'm going to go ahead and store this on this C button in my calculator, since it's C. Alright, so now in my calculator, I'm going to do 180 minus what I have logged in on that C button, which is going to give me approximately 105.7931. Okay, now I still don't know if this is going to exist or not, but I'm going to need this number. So let's go ahead and store it as the letter D. I would like to use C again, but C's already taken. So I believe C2, if it exists, is going to be that approximation we just got, which is the 105.7931. Again, just kind of copying down what I wrote because I've got this big long string of equal signs. All right, now I'm going to automatically go ahead and check and see if the second triangle exists. If it exists, triangle sum must be satisfied. So angle A plus some angle B2 plus the angle C2 that we just found has to give us 180 degrees. If this is going to work, then the angle that I find for B2 has to be positive. So if I plug stuff in, I don't know what B2 is, that's what I'm trying to find. C2 I just identified as D. If I go ahead and solve this equation for B2, it looks like B2 is going to give me approximately 14.2068 degrees. Since this is a positive number, the second triangle exists. And I'm going to go ahead and store this on letter E, just so I can retrieve it again. Okay, now you'll notice that I'm trying to keep my first triangle and my second triangle separate from each other. Now that I know that the second one exists, I'm going to draw a line down to keep these guys away from each other. I don't want the first triangle and the second triangle mingling at all. Alright, so let's see what we've got so far. We've got angle C2 right there. We have angle B2 right there. I need my highlighted be just a little bit thicker. Let's go ahead and make that a little bit thicker. Make it just a little bit lighter as well so it doesn't darken everything out so much that we can't see it. Alright, so there we go. There we go. Alright, better. Now we can see. Okay, so now I need to be able to find, I would think angle A, but angle A was given to me, and so I don't need to find that. I need to find sides B and sides C. So let's go ahead and find B first. So I take the original ratio that was given to me, which is the A ratio. It's going to be sine of 60 over 9 is equal to, right, I want to find little b2. So I'm going to find this now, which means I'm going to set this up just a little bit differently. Instead of having that large B2 there, I'm going to go ahead and replace it with what I identified it as. And B2 I identified as E. So if I manipulate this, it's going to look like B2 is equal to 9 sine of E, since that's where I stored B2, all divided by sine of 60. If I type that into my calculator, and then my B2 is going to give me approximately 2.5505. Okay, so let's see what we got here. I have B2 now found. So if I take a look at the originals, I have a pair of A's, good. I now have a pair of B's that I found, and I have a pair of C's. So it looks like I found everything for triangle 2. Let's go back to triangle 1 and finish that one. So what I have here, let's change our highlighter color so it looks a little bit different. So I have C1, and I've got the 2 A's and now the 2 C's. Looks like I need the B's. So, same idea. To be able to find the first B, I'm going to use triangle sum. And for C1, I stored it in as C, and then A was 60. If I solve this, looks like B1 comes out to be approximately 45.7931 degrees. Pretty sure I'm going to need that again. So let's store that as letter B. So that's another thing that I found. Got B1 now. All right, so let's see, pair of A's, pair of C's, I need a pair of B's. So I go back to my ratio, sine of 60 over the 9 that was given to me is equal to sine of B1 over side length B1. I'm going to do the same thing here. I'm going to cross this out and I'm going to put in what I actually stored it under. Solve that. So B1 is going to be equal to 9 sine the button B, that's where I stored it, all over sine 60. Type this into my calculator, and I get approximately 7.4494. So there's my B1. So again, just to assess, for my first triangle I've got big A, big C, big B, little b. Okay, I'm done. I also have, on the second triangle, both A's, both C's, and both B's. So I think I'm done. It's actually all 6 of those answers that I need to give. Okay, moving on to the next one. The same type of idea here, so what I'm going to do is I am going to find one piece at a time, and I'm going to tell you beforehand what I'm looking for so that you can pause, do that calculation, and then unpause and check and see if we're the same. Then I'll do the same thing for the next calculation. So based off of what I have, I've got a pair of A's. It looks like the only thing I can find right now is angle B. So now would be a good time to pause and find angle B. Okay, so here is my B. I got 58.4844 degrees. Hopefully yours is the same. Now I'm going to assume that there's a second triangle, so let's call this B1. You'll notice that I also stored this in my B button. So let's go across now, and let's find B2. So just a reminder, to find B2, you're going to find the supplement to B1 that you just found. So if we type that in, looks like B2 is going to be 121.5155. I'm not sure I'm going to need this or not, so I'm going to go ahead and store it as D. And again, you can use anything in the alphabet that you want. So this is my B2. Now if this triangle is going to exist, then the missing angle is going to have to be positive in C2. So using triangle sum, if I type that in, if this is positive, this is going to work. And it is. Looks kind of small, but it's going to work. And let's go ahead and store that as E. Alright, so another component to the puzzle. Alright, now that I'm sure that a second triangle is going to exist, right now I am going to find side length C2. So if you want to pause me, now would be the best time, and then we can check. Okay, so for C2, here's my setup. And I ended up with 4.6975 for C2. I'm almost done with this, but on the directions I'm also supposed to find the area. So let's go ahead and find area 2. Now you can use any formula to an oblique triangle that you want. I like doing the half AB sine C or half AC sine B and the other variation of it. So, and since I've stored things, I don't really have to worry about it. So it's going to be half. I'm going to go ahead and use the two sides that were given to me, A and B, which means I have to do sine of C. But my C2 was stored under E. So now take a minute, type that in. I'm going to pause and we'll see if we match. Okay, so it looks like for area 2 I got 24.0278. So I think I'm done with the second triangle. Just make sure I've got 2 A's, 2 B's, 2 C's, and an area. Alright, I'm good. I'm going to go back to my first triangle now. Okay, so what I'm going to do is I am going to go ahead and solve for angle C1. Then I'm going to use angle C1 to find side length C1. So I'm going to do both of those. So now would be a good time to pause, see if you can do those calculations and check. Okay, so here I have angle C1. I ended up with 78.5155 degrees, and side C1 ended up with 17.2430. All right, now at this point I'm going to find area. You decide which area formula you want to use. I'm going to pause, do an area formula I want to use, and we should check then after you're done. So after finishing my calculation for area 1, I ended up with 88.1981. You'll notice that I used a different color highlighter just so I can check back. So just to make sure, I've got two, looking at triangle 1, I've got 2 A's that are given to me, 2 B's, 2 C's, and now area 1. Looks like I'm done with this problem. Let's take a look at the next slide. Alright, so here we've got the word problem from your notes. It's the exact same word problem, so I'm not going to go through and read it. You can go ahead and read it on your paper before we start. So it looks like we need to draw a picture. Alright, so we're standing 40 meters away from the base of a tree. Alright, so here we go, 40 meters away. So there's my horizontal distance away from the tree. That is going to be 40. Then the tree is leaning 8 degrees from vertical. Okay, so that means that I'm going to have a vertical line here to represent perpendicular to the ground, and my tree is going to, or excuse me, it's going to be leaning away from the vertical. Alright, and it says it's leaning away from the vertical by 8 degrees, so this little tiny angle right in here, that's 8 degrees. Alright, then the next part says the angle of elevation from your feet to the top of the tree. Okay, so my feet are way back here, and I want to go to the top of the tree. The angle from my feet, alright, that's way over here then. That's going to be 20 degrees. So here's 20 degrees. Alright, so there's my picture. So I've drawn a picture. Now it says I need to identify some stuff. So known quantities, there we go. Use a variable to represent the height of the tree. Alright, well the tree is actually right here. Let's go ahead and color it green since a lot of trees are green, or at least the leaves are. So there's my tree. All right. So now what I need to do is I need to be able to find out that length of that tree. We're going to write an equation involving the unknown height of the tree, or actually how tall it is, and then we want to find the height of the tree. All right, well, I think what I wanted, I don't want to be misled here by the directions. Height technically implies the vertical distance from the ground. So there's actually a couple ways that we can do this, and I think I'm going to do both just to be clear. We can find that green height, which is going to represent the total length of the tree from the ground to its very peak. But the height of the tree, the height is going to be perpendicular to the ground itself. So I'm actually going to do this a couple different ways. Let's find the green first, and let's just call that T for tree. So to find that, I think I need to do a little bit of work. I know that the 20 and the T go together because of law of sines, but I don't have anything to go with the 40. Let's do some work here. So this angle right in here, I know I could do triangle sum as long as I know all the other angles, and I know that that's from vertical, so that's 90. All right, so to find that angle, I am going to do 180 degrees, which is triangle sum, and I'm going to subtract the other angles that are given to me. So one of them is the 20, that's where my feet are, and then the other one is the vertical and that additional 8 degrees that was given to me. So let's go ahead and subtract all of that. I think that is going to give me 62 degrees. All right, so that little corner right in there, that's 62 degrees. All right, now I can do law of sines. So I'm going to do sine of, well, I can do the 20 over the T for the tree is equal to sine of, okay, now I've got the 62 all over my distance away from the tree, which is going to be 40. Okay, so we've got the setup. I'm going to go ahead and pause and you see if you can find that length of the tree. Okay, so the length of the tree is going to be 15.4944 meters. Now I want to find the height, or, its vertical distance from ground to peak. So let's go back to my picture. I'm going to extend my little dashed line here, and let's make a triangle. So what I'm looking for, actually color in a different color here, let's do it orange, is going to be this height here, because that's its vertical distance from the ground. Let's call that H. So we actually have a couple things that we need to do, and I just think that the question's a little vague, so we're going to do both just to cover our bases here. All right, to find H, I think I'm going to draw that triangle again and just take it out of the picture. So just that little tiny skinny triangle off to the side. Here's the H. I also know that the angle up in the corner is that 62 degrees that we found. So this angle right here, I know that's going to be 62 degrees. And I just found the tree. So let's go back. Let's store this tree under T so we can use it again. Hopefully that's still on your calculator. If we store this as T here, then using right triangle trig, it looks like I have sine. Not law of sines, just plain old sine. So sine of 62 is going to be opposite the H that I'm looking for over the hypotenuse, which was the tree that I just found. And I'm going to go ahead and pause and see if you can solve this one. So if we go through and solve for H, it looks like we get 13.6808 meters, which I hope makes sense to you, because if the tree is leaning, then its top is actually going to be closer to the ground than if it were standing straight up. And that brings us to the end of law of sines. If you have any questions, make sure you ask during class.